let's talk about solving applications of systems of equations. So the first step is to define the variables. The second step is to write out your equations. The third step is to solve using the most appropriate method or methods sometimes, and then write the solution in context. The three methods you want to choose from and the reasons why I put over here. So the first method is graphing. We talked about this one in class. This is best to use when you have both equations in y equals slope-intercept form, or you could easily get them in this form. The second method is substitution, which is best to use when you can easily substitute x equals or y equals into the other equation, and then you could use substitution relatively easily. And 3, elimination. This one's best to use when both equations are already in standard form, so they look like this, where they have the x terms lined up, the y term lined up, and then your constant is on the other side. So let's look at 2 examples. For example 1, let's just look at the problem first. Jess and Jody go to the store. Jess bought 3 pieces of chocolate and 5 pieces of hard candy. She spent a total of $4.25. While Jody bought 2 pieces of chocolate and 7 pieces of hard candy, spending a total of $3.75. How much does each piece of chocolate cost, and how much does each piece of hard candy cost? So first I define my variables. I wrote down over here that C is going to equal the number of chocolate pieces, and H is going to equal the number of hard candy pieces. Then I wrote out my equations. So to represent Jess's equation, she had 3 pieces of chocolate and 5 pieces of hard candy. So I wrote 3C plus 5H, because and would mean I need to add them together. And her total, they told me, was $4.25. So I put her total over there. Then Jody's equation, he bought 2 pieces of chocolate and 7 pieces of hard candy. So I wrote 2C plus 7H equals, and they told me his total was $3.75. I'm going to choose elimination. It's the best method to use since both equations are in standard form, and that way I'm going to be able to eliminate pretty quickly. For this one, I did have to multiply both equations by a number to help me eliminate. So I decided to aim to eliminate the C. So I'm going to turn 3C into negative 6C, and I'm going to turn 2C into positive 6C by multiplying the first equation by negative 2. So I multiplied everything by negative 2 and wrote that down over here. The next step was to multiply the entire second equation by 3, again, because I'm going to try to cancel out the C term, so I wrote that over here. Make sure you multiply the constant. That's one that some people leave out. So then you see I have negative 6C over 6C, so those are going to cancel, but I didn't write it as a canceled out term so that you could read it. I added what was left, so I have 11H is now equal to $2.75, because negative 850 plus 1125 was 275. Then I divided by 11, so I quickly got H by itself. H is 25 cents for each piece of hard candy. But the question asked me about both types of candy, so I needed to plug in the 25 cents into either one of the original equations, it doesn't matter which one, to figure out, so I plugged it in here and solved for C and figured out that each piece of chocolate costs $1 and each piece of hard candy costs 25 cents. Let's look at one more example. Bob and Derek take a cab across town. Bob's cab costs $3 flat rate plus 20 cents per mile. Derek's cab costs $2.50 flat rate plus 35 cents per mile. After how many miles will Bob and Derek have the same cab fare? So I just wrote out that y will equal the total cab fare and m will equal the number of miles, because each one of these equations needs to be written in slope-intercept form. I have a flat rate, which is like my y-intercept, and I have a rate per mile, which is like my slope. So when they say something like flat rate, constant rate, phi, things like that, that's usually indicating that you have a y-intercept. And then per mile represents a slope, so that's going to change for every mile. And so that helps you know that you got to write this kind in a y equals a slope-intercept format. I just wrote the 3 first because that's the way it was given in the problem. Bob's cab cost $3 plus 20 cents per mile. So I wrote it exactly like it sounded in the problem, but you could reverse it so that it is actually in slope-intercept form. And this time I put that graphing or substitution would work, because they are both equal to y, so that you could graph it, but in that case you could also set them equal to each other and use substitution. So with graphing, you could easily type these into your calculator in y equals. You could graph them, you could hit second trace 5, and you could hit enter 3 times. And you get kind of a funky answer, 3 1/3 and 3 2/3. So another way to do it without a calculator is to use substitution. If you set them equal to each other, since they're both equal to y, you can set them equal to each other and solve for m. So I subtracted 20 cents times the number of miles, and I got $3 is equal to $2.50 plus 15 cents per mile. I subtracted $2.50, so I got 50 cents is left is equal to 15 cents per mile. I divided by 15 cents, and I ended up with 3 1/3 miles. So if I wanted to know what the cab fare was, which they did not ask, I could have plugged it back in like I did here to figure out that the total cab fare, when it was equal, was $3.67. And I did have to round a little bit right there to get to 7. So my final solution is after 3 1/3 miles, Bob and Derek will have the same cab fare of $3.67. A little extra information, because the main question was after how many miles, so the answer truly is the 3 1/3 miles. But their total cab fare would have ended up at $3.67.